In AS, when you did binomial expansion, you most likely worked with the NCR notation, right? Now, in A2, we use a different notation and a different formula for binomial. In A2, we use this one. And this one we use when our value for n here, so our power, is a negative number or a fraction. That's when this is more useful. If you notice, there's exclamation marks. There's one here, there's one there, and there's one there. This exclamation in maths is known as factorial. And here's how factorial works. Let's say if I have 2 factorial, I'm going to do 2 times 1. If I have 4 factorial, I'm going to do 4 times 3 times 2 times 1. Okay, so 5 factorial. What do you think that would be? 5 times 4 times 3 times 2 times 1. You get the point, right? That is factorial. That is the binomial expansion for factorial. I believe you do have that on your formula book, but provided you have used this properly and have done enough questions, you won't need to use the formula booklet as a reference. You would be able to know it just off the top of your head. For now, I would say write it down. Have it written in your book and use that when you are going through some questions. Now, let's go over one. Let's try one together, or let me explain one to you, shall I say, and you'll be able to get an idea as to how the notation works. So let's say we have something like 1 over 1 plus x, okay? And we're trying to find the first 4 terms. Okay, the first step would be to rewrite our function 1 over 1 plus x in brackets. 1 plus x to the power of minus 1. We have a negative number for our power, so we can use the factorial notation. In the factorial notation, we always start with 1. Okay, so we do 1 plus, and then it goes nx. So n is minus 1 times by x, like that. Okay, plus, and then the third term. The third term is going to be n times n minus 1 all over 2 factorial. So n times n minus 1 all over 2 factorial, and then it's going to be x squared. So that's our first term, second, third, and now we're going to go one more. So n minus 1, n minus 2, all over 3 factorial times by x cubed. Okay, so now we just simplify it. 1 minus x plus 1 times 2 is 2 over 2 factorial. So it's like doing 2 divided by 2 times 1, which is the same as just 1, x squared. Minus 1 times minus 2 is 2, times minus 3 is minus 6, over 3 times 2 times 1, which is 6. So this is going to be the same as just minus 1, and then x cubed, plus blah, 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 blah. Okay, I hope that made sense. If it didn't, feel free to watch that back. Now, this is also applicable, and it also works if you have a number in front of your x. It's going to work the same way, except here you're going to have bx, and then bx squared, and then, wait, not there, sorry, here, bx squared, bx cubed. That's the only difference. But you would still work pretty much the same way. Okay, so let's have a look at a question where that is the case. We've got 1 minus 2x all square rooted, and we want to apply the binomial expansion until we get to the x cubed term. So, same as before, we're going to convert root 1 minus 2x into brackets. So can you try that for me, please? So you should get 1 minus 2x all to the power of a half. So that means our n equals a half, and we've got the 1 plus bx form where our b is minus 2. That's just something to keep in mind. Our binomial expansion always starts with 1. So 1 plus, and then it's nx. Our n is a half, and then we're timesing that by our x, but in this case it's going to be bx. Like that. The next term, it's going to be n times n minus 1 all over 2 factorial times by your bx squared minus 2x all squared, like that. Okay, next we're going to do n times n minus 1 times n minus 2 all over 3 factorial, and then bx to the power of 3 plus blah blah blah. Our question wants up to and including the x cubed term, which is that last one we just wrote. From here on, you just want to simplify. So can you try that, and can you tell me or see what you get? So you should have gotten 1 minus x squared over 2 minus x cubed over 2 plus blah 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 blah. Your final answers, each term in your binomial should be the most simplified one. Okay, cool. The expansion for 1 plus bx to the power of n is only valid for the modulus of bx being less than 1, or the modulus of x being less than 1 over the modulus of b. So in this case, the modulus of minus 2x less than 1, hope you can see that, that's our modulus, can go as, or be written as, the modulus of x being less than a half. I just take the 2 over and its modulus, so I can ignore the minus part. That part A done. The next part says, by substituting in x equals 0.01, find a decimal approximation to root 2. Right, here's what you're going to do. You are going to substitute 0.01 into your expansion, and you're going to substitute it into your original function. So here's how that works. Root 1 minus 2 times 0.01 should be approximately the same as 1 minus 0.01 minus 0.01 squared over 2 minus 0.01 cubed over 2. So I've substituted into my original function and the expansion. And then you just want to plug it into the calculator as much as you can. After doing that, you should end up with 7 root 2 over 10 approximate 0.9899495. And then from here, you want to rearrange for root 2. And when you do that, you end up with 1.414213571. Okay. Have a look at this question for me, please, and I want you to give that a shot. Okay. Same as always, you're going to rewrite the function in brackets. So 1 plus x in brackets, 1 minus 2x to the power of minus 1. That is your function. And you are going to apply binomial to the second part of this function until you get to the x cubed term, and then you're going to multiply that by 1 plus x. And then finally, you're going to simplify. So let's break it down. You should have something like this. 1 plus n times bx plus n times n minus 1 over 2 factorial times bx squared, and then n minus 1, n minus 2, 3 factorial times bx squared, bx cubed. The rest would just be blah, blah, blah. This all goes in one bracket. Then you're going to have 1 plus x outside like that. So I've applied the binomial only to one of my brackets. After simplifying that large second bracket, you should end up with 1 plus 2x plus 4x squared plus 8x cubed. And now you want to multiply all by 1 and all by x. And then you want to group together. After doing that, you should end up with this. Cool. Part B. State the range of values of x for which the expansion is valid. It's only valid when the modulus of bx is less than 1, and when you rearrange this, it's the modulus of x is less than a half. those are the values for which this expansion is valid. And there you go. That is how you use the factorial notation in binomial expansion.